Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for special probability distribution with the situation normal distribution. So using the Z, where we have standard normal situation with n mean 0 and variance 1. So here notice that Z means that standard normal, where we have mean equals to 0 and standard deviation square, which is equals to variance. So kindly refers to A, where we have the probability that modulus of Z less than K equals to 0.85. So define the situation for modulus of Z less than K. So where we have the situation N. So negative K, Z and K. So here we have the probability. So notice that it is already Z. So means that no need to standardize anymore. So probability that Z is greater than negative K less than K equals to 0.85. So referring to the left hand side, it is a questions, and refers to the right hand side where we have the probability 0.85. So now we are looking for K. So K represent the Z. Second step is to illustrate the situation in a diagram. So kindly refers to the diagram. Next is to locate the value K. So where we have negative K on the left and K on the right. Shaded the region. Modified the situation. So kindly refers to the diagram. We split it into two parts. So here we have the situation. For the first part, so notice that we are going to eliminate the parts on the right hand side. So where we have probabilities that Z is greater than K in order to have the shaded region. Focus on the left hand side. As we all know, our table is only focused on greater than. So my suggestion is to flip the situation. And here we have the situation. So notice that we have the same situation for both sides. So meaning that we are going to eliminate the parts on the right hand side where we have probabilities that Z greater than K. So rewrite the situation. For the first part where we call it A, probabilities that Z greater than 0 minus probabilities that Z greater than K. That is the first part for A. Second part referring to B. Same goes to this part plus where we have probabilities that Z greater than 0 minus probabilities that Z greater than K. So rewrite the situation. If you're referring to the table, probabilities that Z greater than 0 will be equals to 0.5. So same goes to this part. So if we total up, and we will have 1 minus, notice that we have probabilities that Z greater than K for 2 times. So my suggestion is to sum up the situation. So it becomes 2 multiplied probabilities that Z greater than K is equals to 0.85. So rewrite the situation. 2 multiplied with probabilities that Z greater than K is equals to 1 minus 0.85. So if we simplify the situation, and we will have 2 multiplied with probabilities that Z greater than K is equals to 0.15. So simplify the situation. Probabilities that Z greater than K is equals to 0.15 divided by 2. And we will have 0.075. So by referring to the situation where we have the probability 0.075. So in order to find the value of Z, which is equals to K. So here we have the tables of the standard normal distribution. My suggestion is to refer to the middle where we have the probability in order to have the value of Z. So given the situation, or the probability is 0.075. So kindly notice that the maximum value is 0.5. So we need to find 0.075. So kindly refers to 0.07. So in here, we notice that we have 0.07. Same goes to this part, 0.0778. So next, 0.0764. And we have 0.0749, which is the nearest to the value 0.075. So our value will be 1.4, and then we have 0.04. So the value of Z would be 1.44 for the situation. For the probability, 0.075, where we have the nearest probability. So in here, we have 0.075. The nearest value for Z would be Z is equals to 1.44. So meaning that the probability is that Z greater than 1.44, and we will have 0.0749, which is the nearest part. So from here, the value of K is equals to 1.44. Next, kindly refers to question B, where we have the probability that modulus of Z greater than or equals to K equals to 0.1. So define the situation where we have modulus of Z greater or equals to K. It is an OR situation. So Z greater or equals to K, or Z less than or equals to negative K. So where we have the situation probability, so probability is that Z greater or equals to K, or means that plus. Probability is that Z less than or equals to negative K, which is equals to 0.1. So kindly illustrate the situation in a diagram. Locate the value. So where we have negative K on the left and we have K on the right. So by referring to the situation, Z greater and equals to K. So means that here will be the shaded region. Next, probability is that Z less than equals to negative K. So here will be the situation. So kindly split the situation into two parts. So here we have K and greater or equals to for the left hand side, if we flip the situation, plus where we have the right hand side, the value of K. Then we have probabilities that Z greater and equals to K. So we have two similar. So now what we have to do is to rewrite the formula. So probabilities that Z greater or equals to K for the left hand side, plus we have probabilities for Z greater or equals to K for the right hand side, which is equals to 0.1. So rewrite the situation. So 2 multiplied with probabilities that Z greater or equals to K is equals to 0.1. So probabilities that Z greater or equals to K is equals to 0.05. So in order to find the value K, what we have to do is to refer to the probability, where we have 0.05. So kindly refers to the tables of the standard normal distribution. We are going to look for the value 0.05 in order to find the value of Z, or we can say the K. So notice that here we have 0.06. Okay, keep on moving, finding where we have 0.0505. Next, we have 0.0493. So as we can see, here there is no value for 0.05. So the value of Z is in between 1.6, either 1.64 or 1.65. So my suggestion is to refer to another table, where we have the tables of percentage points of the normal distribution. Because previously, you already refined the table for the standard normal. The situation is there is no 0.05. So in here, maybe we can get the value which is more precise if compared to the previous situation. So as we can see, the A represent the probability and the Z sub A is represent the value of Z. So we are looking for 0.05. So as we can see, we have 0.5 then keep on decreasing the value 0.3. So we are interested in 0.05. So in here, the value of Z is 1.6449. As we can see, probability is that Z greater equals to 1.6449, and we can have the probability 0.05. So as a conclusion, the value of K is equals to 1.6449. So here we are, and thanks for watching.